In this video, we want to plan the synthesis of the following compound. Oh, I forgot. I wanted here an aldehyde. Okay, so when I make an aldehyde from that, the first thing, as we said before, is noticing the number of carbons that we have. So let's count 1, 2, 3, 4, 5, and 6. And here I do 1, 2, 3, 4, and 5. So, oh, did I count right? Yeah, right. So it's only 1 carbon more. The strategy that I have been using again, we're selecting reactions for chapters that include alkanes, halo, alkyl halides, alkenes, and alkynes. So the main strategy that we have been using to add carbons is having it an alkyl halide, such as this, react with the anion form when acetylene reacts with sodium amide. That we have been doing, but that adds 2 carbons to the chain. As we know, there's 2 here. 1, 2. And I have here only 1. So I need to come up with something that adds carbon, but I cannot add 2. But if I add 2, I will have to remove 1, if that makes sense. So, but I can make aldehydes from ozonolysis of alkenes. So let's thinking backwards. Let's figure out what alkene would I need. So I would need something like, so I can make the aldehyde here from the ozonolysis of the alkene below. So if I do that, let's see. Now I have, starting from here, I have a compound that has 1, 2, 3, 4, 5, 6, 7. Okay, and I have now what I need. But then I need to make I have here my 6 carbon and an alkene. That's fine. So I can make that alkene. So how do I make that alkene? And I see here from this to that, I have 2 more carbons. But I can add carbons using the alkyne reaction. So let's say that that came from an alkyne. So if I draw an alkyne with 7 carbons, it would be the following: 1, 2, 3, 4, 5, 6, 7, and in carbon 4, 1, 2, 3, and 4, I have that. How do I go from the alkyne to the alkene? I need to do a hydrogenation, but it needs to be partial. So either I use Lindlar catalyst in hydrogen, or I could also use the metal, so sodium and ammonia. But probably we will do Lindlar's, this is 2 separate words, Lindlar's catalyst. So that way we will just add hydrogens. It is this is a poison catalyst. So you stop at the alkene. And here we have the number of carbons that we need. So 1, 2, 3, 4, 5, 6, 7. No, I have gone backwards. And now I can disconnect here. Now, and have that coming from acetylene, thinking backwards. And oh, my arrow should be going here. So thinking backwards, how can I make that from acetylene? Okay, I need an alkyl halide for that part and add acetylene. So let's draw my alkyl halide would need to be. And that I will need to make it react with acetylene and have an excess of sodium amide. Have sodium amide. Okay, hold on. I need to redraw it. Okay. I need to use sodium amide here. to make the anion. And once I have the anion, I can do the SN2 reaction. So I will go from here to there, and I will have added the 2 more carbons that I need. Okay, these 2 will be here. And so let's do my carbons again. I will have 1, 2, 3, 4, and 5, and here's the other 2. So I will have the 7 carbons I need. And now I need to go from here to here. So how do I make the alkyl halide from the alkene that I have above? So I notice that I need to add bromine at the end and the H here. So that means it's an anti-Markovnikov bromination. So halogenation. And to be anti-Markovnikov, what I need to use is peroxide. So that will add the H here and the bromine here and have that. So what we have in summary then in the sequence is it was a bit complicated because we, from 5, added 2 carbons, and now I have 7 carbons. So notice 5 carbon skeleton, 5 carbons. I added 2, now I have 7 carbons, but my final product has 6. So at the end, at the last step, I need to use ozonolysis so that I cut the other carbon that I need. So it was a bit complicated because every time that I use acetylene, I add 2 carbons, and then I needed to remove 1. So that's why we have all that. And so, but again, we can easily make this compound. We go backwards, think of the alkene ozonolysis. Now I have cut the skeleton in 1. And thinking, so from here to here, you have 7 carbons, get to 6. And now, how do you go to the alkene? Well, by partial, say, hydrogenation of an alkyne. And this is what I need to be connecting. So I disconnected here, the alkyne and the alkyl halide. And then I have 7, so that plus acetylene, I have the 7. And here I need to do the anti-Markovnikov. So summarizing, all the steps were from this one here. First, a hydrohalogenation with peroxide. The second step involved the reaction. I need to prepare, I have acetylene and sodium amide. I need to have it react with that. Then I need to use a Lindlar catalyst with hydrogen to make the alkene. And the 4th step is the ozonolysis of the alkene. So that is our final synthesis of the product.